So our last talk for today will be presented by Simon Meggle, and he's talking about Sakuli. So thanks for coming, and it's your stage.
Okay. Thanks. My name is Simon Meggle. I'm coming from Munich. I'm a senior consultant for a company called Console. We are about 200 people, and I'm working in a team of 6 guys. We are doing open source monitoring projects. And today I want to talk about Sakuli, end-to-end monitoring with Sakuli, and the integration of end-to-end tests into monitoring systems. Okay. A short view on the agenda. I first want to define what means end-to-end monitoring and what's the difference to other monitoring methods, how we came to building Sakuli. I will show some slides for the functionality of Sahi and Sikuli, that are the main components we have built into Sakuli, and how that comes to synergy in Sakuli. And then I want to show some demos. The first demo will be on Windows 7. I will first try a simple, stupid functionality test. Then we will have a look at the anatomy of Sakuli scripts. So the minimum set of lines a Sakuli script must have. Then I will do 2 examples, one for Sahi, one for Sikuli, where we see how we can record steps with these tools. And in the end, I will try to connect this service to the Icinga API to get the results in the monitoring system visible. The second demo will show Sakuli running in a Docker container environment. And if there's time left, I will show a small video showing Sakuli testing a web store. And in the end, a few words about performance graphs. Okay. Definition, end-to-end monitoring. When we talk about end-to-end monitoring, we always mean measuring application functionality and quality from the user's perspective. Normally, when we want to monitor a business application, we rely on dozens of monitoring checks, which we try to aggregate with business processes into one service state. But those business processes cannot tell more than, yes, this service has everything it needs to run and it probably should be okay, or there's some component failing and probably my business application is not running properly. But if you want to know more about the application internal functionality and application internal performance, we have to use end-to-end monitoring. So we are simulating an end-to-end user which uses the same test environment as the user also uses. And we are doing the same actions a user would normally also do in the application. End-to-end monitoring is an excellent addition to conventional monitoring systems, and that leads me to what end-to-end monitoring does not mean. It shouldn't replace common monitoring. I think that is a very important point. We do not want to replace common monitoring. It's an addition on top of the common monitoring. And it's also, it has nothing to do with load testing. If we want to test our application when we are executing 200 requests per second, then we should use something like Apache JMeter or something other. Okay, what was our motivation to build Sakuli? On Wikipedia, there is a very impressive list of graphical user interface testing tools, and this list is very long, and each of these tools is good for itself, and each of these tools has its natural limitations. That is, a web end-to-end testing tool can only test web content. It cannot see anything which is outside the browser scope, or cannot test Flash or Java applet contents. Or tools like AutoIt for Windows are made for Windows systems and do not run on Linux systems. And this was our main motivation to combine two of these open source tools together into one new tool so that the two tools can be combined and used together. We wanted to build a modular interface to submit the check results to other systems. We did not want to build in a functionality for Icinga or Nagios or blah blah. We wanted to be able to add functionality in the future by adding modules to Sakuli. And of course, we wanted to be platform independent. Sakuli is written in Java because Sahi and Sikuli also have a Java API. And Sakuli is open source, of course, is released under the Apache license. So let me show you both tools we have packed into Sakuli and how they work. The first component is Sahi. Sahi is a pure web testing framework. It's written by an Indian guy, and it's installed on the test client, which I have drawn here with this blue rectangle. And Sahi can start the installed browsers, which have to understand JavaScript, I think that's clear, with a special profile. This profile defines Sahi, which is listening on localhost 9999, as a local proxy. So when we are recording steps with Sahi, Sahi knows which action we have executed to retrieve a web page, and also knows what the web server have responded. And Sahi has a very big API of methods to access the page returned by the web server. And Sahi doesn't move the mouse or click on something. Sahi has a good understanding of the document object model of the web page, so it knows the structure of the web page. These are three examples of Sahi methods. The first line, assert contains text, will check that the fourth div element on this page contains the text logged in as tnagios up. It's a good readable code, I think. The second example does a click on the span element, which has the ID loaded run IDs. And the third example shows an assert exist statement, which checks if an element exists, and the element I want to check is a table with the ID cross table fixed. As I said, the API is very huge and is very well documented, and we will see some examples later on. Let me head over to the second tool, Sikuli. Sikuli is a pure visual automation tool, and Sikuli can detect regions on the current screen I have recorded before with small screenshots. So in this example, I'm telling Sikuli on the whole screen, this is the object for the whole screen, try to find an image named SAP OK, I have recorded before. And if you have found this region, this is the red square here. Oops. If you have found it, do a click on it. And in case of Sikuli, the mouse is really moved and a real click is done, as the user would also do. The second example shows something similar. On the screen, find this image SAP OK. So we are getting, again, the region here. But then extend this region by 40 pixels to the right. Then do a click in the center of the new created region. This will set the focus in the edit field, and after that type 4 digits into this field. Both tools in comparison. Sikuli seems to be the more universal tool. It can see and handle everything the user also can see. Sikuli is more resource intensive than Sahi, just due to the fact that the screen pattern recognition takes some performance. So you are you should use always regions you have defined for yourself to match the images. If you have a big fat screen and you're always searching small images on the whole screen, this will take much more resources than you have a small region and you tell Sakuli, please search only in this region. You can define as many regions as you want. Sakuli also needs always a clear view. If you have an antivirus scan running at noon, at 12 o'clock, always showing a nice pop-up that it's starting a regularly scan, chances are that this pop-up window will cover items Sakuli needs to check. So if you want to run Sakuli tests, you have to ensure that every screen locking mechanism, screensaver, pop-ups, update, whatever, has to be hidden. Not disabled, but hidden. Sahi, on the other hand, is, as I said, limited to pure web content, so we cannot test Flash or Java applet content. Sahi is very fast, as we will see in the demo, and Sahi code is very efficient to write because it also includes recording functionality. Sakuli covers both tools so that we can use both within one test. That means we can change the tool line by line. The step itself is written in JavaScript, and in case of an exception, may it be in Sahi or Sakuli or in the framework itself, will always trigger a screenshot which can be handled to the forwarder modules. We are able to execute Sakuli tests headless, only in Linux. That means running Sakuli in XVNC sessions, so in a virtual display, and in Docker containers. That makes Sakuli a very flexible and scalable solution to do more than one end-to-end test at one time. And as I explained, the forwarder modules submit the results to different third-party systems that are monitoring systems like Nagios or Icinga, writing the results into databases, or forwarding to logging systems like Splunk or Logstash, or to integrate Sakuli tests into continuous integration processes. So at the end of your build queue, you can run a Sakuli test to check if your application is also working in the graphical user interface. Okay, first demo. I will try to execute the functionality test and introduce into the anatomy of Sakuli scripts, record some steps and connect to the Icinga API. A few words before, I have already installed Sakuli on the test client. This is a screenshot of our new graphical installer, and just to explain some points, this will install Sakuli version 0.9.3, the current stable. This version also includes already the Sakuli libraries. Sahi is installed as a separate module, version 5. We will set this version as default version. This point changes some Windows settings, disables visual effects like fancy glooming, transparency effects, so everything you do not really want to have in end-to-end tests. And we are also delivering Firefox Portable to have a separate browser available only for end-to-end tests. And QRS is a small open source tool to change the settings of the resolution and color depth by command line, used by some customers, and we have included it. Okay, head over to the demo. Yeah. This is a Windows 7 system, and the first thing I'm always doing with a fresh Sakuli installation is executing the example test, just to test that both components are working properly together, Sahi and Sakuli. Sakuli is our generic test starter. Without any argument, you will get a help. Sakuli run, C, program files, Sakuli example test suites, example Windows 7, and I want to choose the browser Firefox Portable. Sakuli will now open the start page of Sahi, check some links on this page. After that, open the Windows calculator, do some very complex calculations, and after that, display success message in the Windows Notepad. This is the Sahi start page. Checking the links, open the calculator. That's it. Very simple, very stupid, but it shows how both components can work together. Okay. Let's open a Sakuli script to see how this is defined. Yeah. This is my folder containing all the test suites. Example Windows 7. Here you can see all the screenshots I'm using for my test, and Sakuli demo.js is the script I want to show. Okay. Each Sakuli test contains a try, catch, finally block. And as you can guess, everything you write as your code belongs to the try block. On any case of an error, Sakuli will execute the catch block. And in the end, in every case, we are executing the finally block to close or kill applications and send the result to the forwarder modules, which sends them to Nagios or other systems. In the head of this file, there are some include instructions. Test case is the test case object containing the thresholds 60 and 70 for warning and critical. So this test is not allowed to run longer than 60 or 70 seconds. Env and screen are default objects we need to run with Sakuli, and we are creating two object items for application items to start the Windows Notepad and the calculator. Okay, now I want to show how we can record small steps with Sahi and Sakuli. So how do we get two lines like this? First I want to show how this is done in Sahi. So if we want to test anything web related, we will use Sahi for this. I'm starting from Sahi user data bin, the so-called dashboard. Dashboard allows me to start every browser on my system which is able to use Sahi as a local proxy. And the first browser here is Firefox Portable. Okay, you know this page? This is the Sahi start page. And to record some steps, I'm following the instructions here. I'm pressing the Alt key and double-click anywhere on the page to bring up the Sahi controller. The Sahi controller is very useful to identify items on the web page and use them later in my script. And the funny thing is, when I'm holding the control key and moving the mouse over the page, I'm getting accessor functions which allow me to access the elements on this page. So for example, for this go button, I'm getting the accessor method _submit, which needs an identifier. So I want to access the submit button labeled with go. I can test if I have hit the right one with highlight. Sahi will mark this button with a red border. And now I can simply copy out this line into my test case. This is a very simple way of recording steps with Sahi. You can also define a script name in which you can record all the steps you are doing in the browser. And after that you click on stop, open the file and copy everything you have recorded by the Sahi controller into your Sakuli test case. But we do not only want to highlight an element, we also want to ensure that it's existent. Sahi has this assert button here, which writes me some proposals for check functions. I'm choosing assert exists, which simply checks if an element is really present on the page. And this is submit go. I also copy this in my script here. There are many other things you can do with Sahi. As I said, the documentation is very good. I want to head over to Sakuli, how we can use Sakuli in our script. I'm closing the controller again. Now I want to have Sakuli, let's say, click on this button here. So this is something outside of the browser scope, which we cannot access with web testing methods. I simply do a screenshot of this region. Save. Yeah, here it is. Button 1. Now change to the Sakuli script. I'm telling Sakuli on the current screen, wait for image, the image called button 1, and wait for maximum 10 seconds to appear. If you have found this image, click on the result region with the left mouse. There are other functions too, as I explained. Find, highlight. I can also add an highlight. Highlight. So Sakuli will first search this image, highlight the element, and then click on it. Sorry?
The extension of the file?
I do not need the extension. It's okay to only type the name in. Thanks. You can use JPEG and PNG, but I would recommend PNG to have images without any compression. It's very important, as you can guess. Okay. Now I'm closing the browser window and I will try to execute the same test again. Now we should see Sahi checking the go button and Sakuli clicking on this whatever button. Yeah. Okay. It worked. The last thing I want to do with this small demo is to integrate the result of this check now into Icinga. The integration of the Icinga API client is a very new feature. And this is just a new forwarder we have written beneath the database forwarder and the Modgearman forwarder for Modgearman-enabled monitoring systems. I show you the lines you have to use. Everything in Sakuli is defined by property files. there are 3 different kind of property files. Sakuli default properties located in the Sahi home config folder shouldn't be changed. You simply have to copy these lines into Sakuli properties. This is a file located in the folder where all the test suites are stored. And in this file you can override the default properties. So I'm setting Icinga 2 enabled to true. Icinga 2 host name is the Icinga host object. In the Icinga system, I have my services on for my Sakuli checks. In this case, Sakuli client 01. RPE host is the IP address of my Icinga host, port, username, password, and URL is the URL which is formed by these variables. And if I'm scrolling up, there's somewhere this part where I can see that Sakuli has already sent the results to the Icinga server. Icinga responded with 200 response code, successfully processed check results for object blah blah. Let's see how this looks like in Icinga. This is my check. Okay. Sakuli suite, Sakuli Windows 7, okay. This is the total suite runtime, and the last suite run at 17.7. Yes, that's okay. Here are probably some performance graphs, not in my demo system. This table here is showing the performance data, not meant for human to read. They are used by graphing systems like Grafana or PMP for Nagios. And yeah, okay, that's my first demo. The second demo will show Sakuli in a Docker container. A few sentences before, normally following the Docker philosophy, you would start a Docker container for each Sakuli check. So only for one Sakuli run, fire up a Docker container, which is very fast, and after that destroy, and then the next container starts. In my example, I have a container which is starting Sakuli test with the argument loop 10, which simply means execute this test in an endless loop and do a 10 seconds break between the tests. The results are then sent to a Niemann monitoring core. I have a second container instance running OMD, the Open Monitoring Distribution, also inside a Docker container. And in the end, I will show what's happening when I'm doing something wrong in my test, or if something goes wrong. Yep. This demo was originally made for a German IT magazine to show Sakuli and OMD in combination to make it possible for everyone to simply pull the Docker containers and start the whole system. I have defined both containers in Docker Compose. The first container I'm starting is my Sakuli container. It's based on the image Sakuli Ubuntu XFCE. It's a Ubuntu image installed with XFCE as desktop environment, which is very fast and lightweight. The check script itself is located outside of the container, so I'm able to change the scripts outside of the container, and I do not have to rebuild the Docker container. Yeah, I'm exporting some ports for VNC. This is the command I'm actually executing within the container with loop 1, and I'm linking to a container for OMD Labs, our Labs edition of OMD, which is based on Ubuntu image as well, and I'm exporting port 8443 to connect to the web interface of this instance. Okay. Okay. Yeah. Docker compose up. Now we can see the OMD side and the Sakuli container starting, and the Sakuli container instantly starts executing the test case. To be able to watch what's happening, I have a VNC viewer here. It's HTML based. Now I'm connected to the XVNC session within the Docker container on virtual display 1. So we should see the test running again and again, again and again. Yeah. Okay. And the result should now be visible in my OMD site, running the web interface truck. It's a web interface written by console. Some might be reminded to the original Nagios interface. It's it's a web interface with more functionality, and I have here one host and one service defined for my Sakuli test, and this is the result from my Docker test, last executed in 1714. So this is indeed the result of the test running inside the Docker container. The service details show the same things you have seen already in the Icinga web interface, performance data, and here is space for some nice graphs. I do not have in this environment because it has already started. Okay, now we are trying to sabotage. I'm changing the script file so that Sahi cannot find one element on the start page. The script is located in the folder example xfce. So now I'm on my machine, on my Mac, and the folder example xfce is mounted as a volume into the Docker container. And now I'm editing the Sakuli demo case, and so let's change the last highlight statement to something which Sahi wouldn't be able to detect. Okay. Starting again. Now we can see the test running on the Sahi start page, checking all links, but not the last one. There's a default timeout of 10 or 15 seconds, and after that, Sahi raises an exception, which is received by Sakuli. Sakuli takes a screenshot of the current picture and destroys the test case, closes all applications, and then the test runs again. Let's see how this looks like in the monitoring interface. Now I can see the check has turned critical, of course, with a large error message and the screenshot image of the error situation, so that I can see how far the test did run and what the error was. Perhaps now I would see some error message in my application just to document the failure. Okay, this is something I wasn't able to integrate into Icinga Web 2 because there is some fancy PHP component which strips out HTML elements and also replaces semicolon by a double colon, and this image is transferred via the service output of the check, and we have to encode the image as space 64, and for this we need semicolon. If there's someone with a great idea, perhaps we can talk how to solve this problem. Okay. Next small demo is not really a live demo. I want to show a small video of Sakuli running against a web shop. This is a longer test. I want to explain what's happening. Sakuli should log into my web shop, should empty the basket to have a clear starting point, put some items into the basket, print the order summary into a PDF file, open this PDF and check its contents. Okay. You're seeing this test within a Ubuntu VM. And this test is also running in a XVNC environment. So if I do not connect via VNC to the virtual display 1, I wouldn't see anything. So this test is completely headless. So now I'm connected to my fresh XVNC desktop session. This is my web shop in a virtual box. Logging in, I'm clearing the basket. Now I'm ordering some items. Checking the order summary. And now, pause. This is the point where the Sakuli part takes over. This is something we cannot do with Sahi. Sakuli has pressed Ctrl P to open this dialog, enter a file name to print this page into a PDF. And then Sakuli opens the document viewer, opens this file, checks the contents, and closes everything. Okay, then the session is destroyed, and yeah, everything can run from the beginning. This is an example graph of PNP for Nagios. I have written this template for PNP, and you can see the steps. One thing I have forgot to mention, a very nice feature in Sakuli. This is my demo case. End of step. Test case end of step is a method to define some markers within my test case to divide it into logical steps. So I can measure how long did it take to log into my application, how long did it take to create a report, to do blah, blah, blah. And I'm also giving a threshold. So this step is not allowed to run longer than 30 seconds, otherwise the whole check will turn warning. It's a very nice feature to monitor performance bottlenecks. And this graph exactly lists all these steps in the correct order and how long they took. The orange ticks on top of this graph show where Sakuli did not finish the check, where some performance data are missing. This is the total runtime of the check. Yeah, and I also included some host statistics. The yellow line in this graph is displaying the CPU load on this test machine to be able to interpret some runtime spikes with the CPU load on the system. And yeah, for Icinga 2, I was able to integrate the PNP template, which wasn't that hard, but there are no templates currently for Grafana or Graphite. So if there's someone with Grafana skills, then yeah, you're welcome. What's next? This is where we want to go with Sakuli. We want to have a central Sakuli instance, which is only responsible for the scheduling of Sakuli checks. The checks are then put into queues, and below this central instance, we have a, I call it swarm of workers, of Sakuli workers, which register to all these queues and pull out the jobs they have to execute. And if they are finished, they are sending the result into the result queue of the central scheduler, and the scheduler is responsible for storing the results into a database or forward it to Icinga or log systems or anything else. Okay, yeah, please join, please fork, please pull request, please everything. Yeah, let me know if you are, if you can use Sakuli, how you can use Sakuli. We are on GitHub, of course. There's also documentation. We have a web page. We are on Twitter too, and yeah, any questions so far?
Questions?
For the Windows part, do I need to continuously log on the user, or can it be that the user, the script logged on in as a user, run the test and log off?
That's not possible. So if you find some solution to run headless test on Windows, let me know. That's a big question we still have. In Windows, you indeed would have to run the test client with an unlocked session, and you have to ensure that nobody has still access to this machine.
Okay, thanks.
Yeah.
More questions? Thank you very much for the talk.